In this video, we will learn how to create a stacking cards effect like this one. Before we go to the code editor, it's worth mentioning that this demo was inspired by a demo created by Bramos. If you go to scroll-driven animations.style, there are many examples here, and one of them is stacking cards. If we click on CSS version, and if you start to scroll, you can see it's the same as the example we're going to implement. So this is the same example, but I removed the animations from it so we can implement it ourselves. All you need to know about this HTML is that we have a cards element which contains all the cards here, and for each card element we have a div with a class name card, and each one has an ID with card, hyphen, and the number. For example, for the first one we have card 1, if we scroll, the second one has card 2, and then card 3. In this example, we're going to implement that with only 3 cards, but it should work with as many cards as you want. Now let's go to the styles and see what we have for cards. So for the cards container, we are defining a variable for the total number of cards. In this case, we have 3 cards, so we are saying total cards 3. And for that container, we are setting the display to flex and making the direction to column and gap to 30 pixels, so we have gap 30 pixels between each card, and the width 100% and maximum width 900 pixels. And we are centering it using margin 0 auto. Now for the card, we only have transform origin top center, which we will use later when we apply transform scale. Now for each card item, we are setting an index variable. For example, for the card 1, we are setting index to 1. For card 2, index 2, and so on. Now the reason I have defined an index variable for each card is to avoid replicating some CSS code when we are styling the cards, which would make the code more usable, especially when we have more cards. So for example, let's say I want to set the top property for each card to be 20 pixels bigger than the previous one. For example, let's say that for the first card, top should be 20 pixels. And for card 2, top should be 40 pixels. And for card 3, top should be 60 pixels. So I can do this, but with the index variable, I can do the same more dynamically. So for example, what I can do, I can remove all of them and go to the card class, which is common for all of them, and then I can say top, and then I can use calc and say index times 20 pixels. Which means for the first card we have index 1, so it will be 1 times 20 pixels, it will be 20 pixels, and for card 2 it will be 40 pixels, and card 3 would be 60 pixels, and so on. Before we define the animation, we need to set the position of each card to be sticky. And that's because we want the card to stick to the top of the viewport when we scroll down. So now when I scroll down, you can see that the card didn't stick to the top of the viewport. To fix that, we can set the position to sticky, and that will do it. So let's go to card and say position sticky. So when we save, let's try that again. So when we scroll, it sticks, and the second one, and the third one. And you can see there is a different top space for each card. And in this case, it's 20 pixels because we set the top to increment by 20 pixels for each card. But for example, if we set it to 0, it will be like this. So all of them will stick when they hit the top of the viewport. But in our example, we need a 20 pixels margin for each one. So now it looks like this. Now it's time to define the animations. To make things easier to work with, let's apply the animation for the first card only. And after we do that, then we can apply it to the other cards. So the first card has this ID. Let's define the animation for the first card. Let's say animation, stacking, 1, linear, forward. Let's define the animation below, keyframes, stacking 1, and what this animation should be. In this case, we want to scale the card down, because the animation will be, like when we scroll and it hits the top of the scroll port, it should start to shrink to a certain point. And let's say we want to shrink it to 90%. So we're gonna use 2 and transform scale 0.9. But now what about the animation timeline? We are applying animation for each card, so that means we need to use a view progress timeline. So for the animation timeline, we're gonna say animation timeline, and let's use anonymous view. For the animation range, the first one comes to my mind is exit, because I imagine that the card will start animating when it hits the exit point. So we can say animation range and exit. But do you think that will work? Let's save and try. So nothing happened here. And that's actually expected. Because think about it, animation range exit means that the animation will run while the element is exiting the scroll port. But in this case, the element is still sticky here and it's not exiting the scroll port. So we can imagine that the animation will run when we scroll further like here. But in this case, we can't see the animation, and that's not what we want. In our case, we want to run the animation the moment the card hits the top of the scroll port, something like this. So when we scroll, once we hit here, the animation should start. So that means this is not an option that we can use. But then how can we implement this? I got the solution I'm going to show you from the demo by Bramus. So you can see we are using anonymous view timeline for the animation timeline, which means that the card is the subject and the element to animate. But instead of that, we're going to make the card's container as the subject and then animate the cards based on that. I know that this might seem a little bit weird at first, but I'm going to explain why this will work. To make it easier to explain, I'm gonna set some background color on the card's container. So let me scroll up here and say background color, let's set blue violet and save. So you can see how the card's container is wrapping all the cards like this. So let me explain what the issue is again. We can't progress the animation when we are scrolling because the cards has a sticky position. And when we scroll like this, the cards don't move beyond the sticky point. But is it the same for the cards container? Let's scroll more and see. So you can see how the cards container is moving normally when we scroll. And to make it easier to see, I'm going to hide the cards. So let me set the opacity to 0. So let me scroll more. So you can see how the cards container is leaving the viewport like any other normal element. And that works because it doesn't have a sticky position, unlike the cards. And that means we can progress the animation using the cards container. And for example, we can set the animation range to exit and the animation will work correctly because it's leaving the viewport as expected. So let me demonstrate that by changing its color. So let's go here and I'm going to define a new animation. Let's say change color. And let's set the animation timeline to view and animation range to exit. Let's define the animation below, keyframes, change color, and let's change it to yellow. Let's try to scroll. And it works as expected and nothing is new here. But the question is, how can we use the card's container to progress the animation for each card individually? So if you remember when we were learning about view timeline in the view timeline video, we learned how you can define a single subject and multiple elements to animate. And for each element to animate, you can define a different animation range. So in this example, the card's container will be the subject, and each card will be the element to animate. And for each card, we can define an animation range to specify where the animation of each card starts and when it ends. For example, for the first card, we want to start the animation when the top of the card's container hits the top of the viewport, like at this point. And the animation will end when we scroll the same as the height of the card. So for example, it will be like this. The animation will start here when it hits this point, and then it will end when we scroll this amount. And then for the second card, the animation will start when we scroll more and this line hits the top of the viewport, and it will continue to animate until we scroll the same amount as the height of the card, somewhere like this. And the same for the third card, when we scroll more and this line hits the top of the viewport, the animation will run until we scroll the same as the height, which in this case will be here. So it will look like this. When the card's container hits this point, the animation for the first card will start, it will continue to animate to this point. And then we will hit the second point in which the second card will start to animate, and we will animate until this point. And at this point, the third card will start to animate until we scroll to the end. But now the question is, how can we define these animation ranges? So let's try that on the cards container, and then we will move the animation timeline code to each card. So let's try this. So for the animation range, we are using exit, which is the same as saying exit 0% and exit 100%. So for the start of the animation range, it will be at the top of the viewport. And since it's 0%, then we are right at this point. Now, if we increase it, then we will move that point up. And when we use exit 100% for the animation range end, it will also set that point at the top of the viewport, which would make the scrolling length for the animation 100% of the height of the element. So that's how I think about it. I look at the start point, it says 0%, so it will start right at this point, at the top of the viewport. And then I look at the end of the animation range, and it tells me how much the user is scrolling while the animation is running. So when it's 100%, you will need to scroll for the full height of the element for the animation to end. And if you set it, for example, to 50%, it will still start at the top of the viewport, but the scrolling length will be half the height of the element. So let's try that. So I scroll, it hits the start point, so the animation starts, and when I scroll, it will continue to animate until I scroll 50% of the height of the element, somewhere like this. And if you remember, our goal is to make the scrolling length the same as the height of the card, not the card's container. And I know in this example that the card height is 367 pixels. So let's try that. So let's update this to 367 pixels. Now let's try again. So when I scroll, the animation will start here until I scroll the same as the height of the card. Like this. So that will take care of the first card. What about the second card? If you remember, the animation range start determines where the animation starts. So when it's at 0%, it will be at the top of the viewport. What if we push it up by the same amount as the height of the card, which is 367 pixels? Let's say 367 pixels. Let's save and try. So when I scroll, the animation will not start here. It should start after I scroll 367 pixels, which is the same as the height of the card. For example, here. But you can see the animation didn't run. It reached the end of the animation instantly. And that's because you have to use the same offset at the animation range end. So it will be 367 pixels plus 367 pixels. The first one is the same as the start. And then you determine the length of the scrolling. But of course we have to use calc for this. So let's say calc. Let's save. So we scroll, the animation doesn't start until we reach 367 pixels. And that's for the second card, it will start to animate until we reach this. And what about the third card? Again, we have to update the offset. It will be 367 pixels plus 367 pixels, each one the same as the height of the card, or we can just multiply it by 2. Calc times 2, and we have to use the same offset here. So paste it here, and let's save. So for the third card, it should start somewhere here, and then it will start all the way to here. So you can see, with this approach, we divided the card's container into multiple areas, each one for each card. The start of the range determines the start point for the card. The end of the range determines the amount we should scroll to reach the end of the animation, but for that to work, we always have to add the same start here, which is the offset. And a quick note here, although exit works here, it's better if we use exit crossing, because in this case, the height of the card's container is smaller than the viewport. But in cases where it becomes longer than the viewport, then it will not work. To fix that, we can use exit crossing, which will give us the same result as this. So let's use exit crossing here and here. So we've been running the animation on the card's container, but it should be on each card. And that's easy to do. All we have to do is to define the card's container as the subject, and then we can use that subject to progress the animations on the cards. So we can remove these, and let's define it as a subject by saying view timeline name. And let's give it the name cards container. And also let's remove the background from here, and let's go to the cards and show them. Now let's animate the first card. So now instead of using anonymous view timeline, let's use the subject we defined above. So let's use cards container here. And let's define the animation range as we just learned. So we will use exit crossing. For the first card, it will be 0%. The end will be the same as the length, which will be the same as the height of the card. So let's say exit crossing, and it's 367 pixels. And for this animation, actually, I'm gonna make it 80%. So let's set the scale to 0.8. Let's save and try. So if I scroll, you can see how the first card is shrinking. So that works. Now let's define the second card. Let's go down, and actually let's copy this here, and paste it here, and let's call it stacking 2. Let's copy it, paste this, and modify it to make it 2. And for this one, it will be 90%. Now what about the ranges? And remember, the offset will be the same as the height of the card. So it will be 367 pixels. And let's add that offset to the end. Let's use calc. And actually we can just multiply by 2, because in this case the offset and the height is the same. Let's save and try. So you can see the first and the second cards work. Now what about the third card? In this case, the third card should not change its size. But I'm going to define the animation anyway to make the code more consistent. So let's copy this. Go here, paste it. Let's also copy stacking 2 here. Name it stacking 3. And for the scale, it will be 100%, because we don't want to change its size. And let's update this to be stacking 3. And again, the offset will be 367 pixels times 2. And this will be times 3. Because remember, we are using the offset, which is 367 pixels by 2, plus 367, which is the same as the height, but I'm just saying times 3, which is the same. Now if we save, let's try. So you can see the third card doesn't change because we just set the scale to be 100%. But if actually we change it to something else, like for example, let's make it bigger, you can see how it will run, and it becomes bigger. But let's get it back to 100%. Now everything works, but let's clean up the code and make it more reusable. Let's start with the card height. So instead of hard coding 367 pixels for the card height, let's define a variable for that. And we will define it in the cards container. Let's define it below total cards. Let's say card height and 367 pixels. Or we can make it more responsive by dividing the full height of the cards container by the total number of cards. So we can use calc for that, like this. Calc 100% divided by total cards. Now the reason this will be responsive, because when you divide the full height of the cards container by the number of cards, you will get the card height including the gap. So remember, we have added a gap between cards, this one, which is 30 pixels in this case. Now if we change it to something else, it will be picked up by this simple math. And including the gap here will make the animation look more consistent. Now let's replace all the hard-coded values with this variable. So let's go to 367 pixels. And we will replace this with var card height. Let's go to card 2. Let's replace this and this. And card 3. Let's replace this and this. Let's save and see if everything is still working. Okay, cool, everything is still working. Next, we will replace all the animations, stacking 1, stacking 2, and stacking 3 with a single animation. Let me show you how. Let's scroll here, and let's define a new one called just stacking. And it will be the same, transform, scale. And here's the formula I'm going to use. Don't worry if it looks confusing. I just used some simple arithmetic sequences to create this formula. So let me show you how it works. So this is how the formula looks. 1 minus 0.1 times total cards minus index. Let's try to substitute that for each card. All the cards will have the same total number of cards. So this will be 3. And for the first card, index will be 1. So 3 minus 1 is 2. 2 times 0.1 is 0.2. 1 minus 0.2 is 0.8. Which is correct. The second card is, the index will be 2. 3 minus 2 is 1, 1 times 0.1 is 0.1, 1 minus 0.1 is 0.9, which is also correct. And the third one will be 3 minus 3 is 0, 0 times anything is 0, 1 minus 0 is 1, which is also correct. So let's try this and see if it's working. So I'm going to remove these comments, and let's remove the other animations. Let's remove this one, and stacking 2, and stacking 1, and let's switch the animations to them. So card 1, it will be stacking, and card 2 will also be stacking, and card 3 will also be stacking. Let's save and try. Okay, cool, so everything is still working. Next, let's see how we can extract these 3 lines and use it on the card class to make it reusable for all the cards. But first, let's see what the relationship is between the numbers and the cards. For example, you can see in card 3, we have the number 2 here. And for the animation range end, we have the number 3. Let's see card 2. For card 2, for the range start, we don't have anything here, which is the same as saying times 1. And for the range end, we have 2, which is the same as the index. Let's go to card 1. You can see that this is 0, which is the same as saying card height times 0. And for the range end, it's the same as saying times 1. So let's see if we can use the index variable instead of these. So for card 1, the start range is index minus 1. And the end range is the same as index. Let's see if this is the same for card 2. For start range, this number is the same as saying index minus 1. And the second number is the same as the index. Let's see if that's the same for card 3. This number is the same as saying index minus 1. And this number is the same as the index. So from that, we can see that for each start range, we are using index minus 1, and for each end range, we are using index, which is the same as saying var index, and this as var index minus 1. So let's try to move these 3 lines to the card class and see if the animation will still work. So let's cut these and scroll to the card and paste it here. As you can see here, we are not hard coding any value here, and instead we are using the index variable. Now let's remove all the animations from the other cards. Let's remove these, and from card 2 as well. And we've already removed it from card 3. So this is what we have here. Next, let's split animation range into 2 properties to make it easier to read. So let's say animation range start and animation range end. So now let's save and see if everything is still working. And cool, that works. Now last but not least, let's make the cards darker when they are shrinking. So let's go to the stacking animation and let's animate brightness for that. So let's say filter, brightness, and let's make them 50%. So let's try that. You can see how it gets darker. But notice how the third card is also getting darker. But it's better if we don't run that animation for the third card. And the best way to do it is to move the brightness value into a variable, and then we can specify that for each card. Let's call that variable target brightness. Let's define it in the card class. So the default one will be 50%, and then I'm going to override that for the third card. So let's go down and paste it here, and let's set it to 100%. Now let's save and try. So the first one gets darker, the second one, and the third one is not affected, which is what we want. And with that, we have created a stacking cards animation using CSS.